All right, class, in this video, this is the last video in our discussion in section 4.6 in your textbook on modeling with exponential functions. We're going to start top of page 6 of your lecture note handout. And so we're continuing with another example involving Newton's law of cooling. So in this example, we're given a roasted turkey is taken from an oven when its temperature has reached 185 degrees Fahrenheit and is placed on a table in a room where the temperature is 73 degrees Fahrenheit. So the initial temperature of the turkey is 185, and the temperature of the room, right, the air in the room, in the kitchen, I guess, is 73 degrees Fahrenheit. If the temperature of the turkey is 150 degrees Fahrenheit after half an hour, what is the temperature of the turkey after 45 minutes? So in this problem, okay, we know that T sub S, the temperature in the room, is 73 degrees Fahrenheit, and because the temperature in the room is 73 degrees Fahrenheit, the initial temperature of the turkey is 185 degrees Fahrenheit. D sub 0 is 185 minus 73, which is equal to 112. And then we also know that the temperature of the turkey, capital T, 1/2 hour after it's removed from the oven is equal to 150 degrees Fahrenheit. Remember, 1/2 is the same as 0.5. What we don't know in this problem is the value of K in our model. So remember, this is our basic model down here. The temperature, capital T, at time little t is equal to the room temperature plus the difference between the initial temperature of the turkey and the room temperature times e to the minus kt power. So we can substitute 73 in for T sub S, 112 for D0, and now this is what our model looks like. And so to figure out what K is, we're going to use this data point up here. We know that the temperature at t equals, little t equals 0.5 is equal to 150. So we put in 0.5 in for little t up here. And we have capital T at 0.5 is equal to 73 plus 112 times e to the minus k times 0.5 power. Well, t of 0.5 is 150. So that's equal to 73 plus 112 times z to the minus 0.5 k power, right? I just switched the order of multiplication. And now we solve for k. So, solving for k, right? First step, subtract 73 from both sides, get 77 on the left. And then we want to isolate the exponential e to the minus 0.5k. So we divide both sides by 112 and get 0.6875 on the left. And that's equal to e to the minus 0.5k power. So in solving for this, right, I'm going to use the natural log function. I take the natural log of the left-hand side is equal to the natural log of the right-hand side. And by property of the natural logarithm, the natural log and the e cancel. Natural log of e to the minus 0.5k is just equal to this exponent minus 0.5k. And now we're solving for k. And so, you know, the next step is to divide both sides of this equation by minus 0.5. And when we switch the two sides of the equation, we have the natural log of 0.6875 divided by minus 0.5. That's equal to k. So using your calculator, right, this numerator divided by the denominator to 5 decimal places is equal to 0.74939. Rounded to 5 decimal places, k is equal to 0.74939. So now we take this value of k and we plug it in for k up here in our model, okay? And for k up here. And when we do that, we have the temperature at time t, right? The temperature of the turkey at time t is equal to 73 plus 112 times z to the minus 0.74939 t power. And now we can calculate what's the temperature of the turkey after 45 minutes. Well, 45 minutes out of 60 minutes is 3/4 of an hour, or 0.75 as a decimal. So the temperature of turkey, right, capital T 0.75 is equal to 73 plus 112 times E to the minus 0.74939 times 0.75 power, right? We just put in 0.75 in for T up here. And this product in the exponent is equal to minus 0.562. And now you got to follow order of operations, right? Using your calculator, E to the minus 0.5620425 power is equal to this number in parentheses. You multiply it by 112 and you get 63.8. You add it to 73 and you get 136.8 degrees Fahrenheit. So the temperature of the turkey after 45 minutes after being removed from the oven, right? The temperature of the turkey 45 minutes after it's removed from the oven is 136.8 degrees Fahrenheit. It came out of the oven at 185 degrees, and 45 minutes later it's 136.8 degrees. All right. The top of the next page, you're asked after how many hours will the turkey cool to 100 degrees Fahrenheit. So going back up here to our model. Here's a model right here. I lost it. Sorry about that. So here's our model right here, and we will say how long does it take for the turkey to cool down to 100 degrees? Well, we replace capital T of T here on the left with 100 degrees. And when we do that, we have 100 is equal to 73 plus 112 times Z to the minus 0.74939 times T power. Now we got to solve for little t, right? So we subtract 73 from both sides, get 27 on the left, and then we divide both sides by 112 and get 0.24107 on the left. And now we got this number is equal to the exponential on the right, e to the minus 0.74939 t power. So again, we take the natural log of both sides, and we have the natural log of 0.24107 on the left. The ln and the e cancel on the right, and we're left with the exponent, minus 0.74939 times t. Now we divide both sides by minus 0.74939, switch the two sides of the equation, and we get little t is equal to natural log of this decimal divided by negative 0.74939. And so when you do use your calculator, do that division, and round to one decimal place, you find the time it takes for the turkey to cool down from 185 degrees to 100 degrees Fahrenheit is 1.9 hours.